Okay, last question, question 12, and I think, yes, this is a difficult question. So 12a, well, a and b is okay. So it says show that f is an even function. So hopefully, guys, you know for an even function, f of x, well, let's write it here, f of x must equal f of minus x. That's what an even function is. So f of x is that. We just need to find f of minus x. F of minus x is equal to arc sine, this is actually quite easy, guys, minus x squared minus 1 over minus x squared plus 1, which is equal to arc sine x squared minus 1 over x squared plus 1, which is equal to f of x. Therefore, you can just write f of x equals f of minus x, therefore even. That does seem like a lot of work. Well, it's not that much work, but it's only 1 mark, unfortunately, but c'est la vie. Okay, part B, let's do here, guys. It says, by considering limits, show that the graph has a horizontal asymptote and state its equation. Right, the horizontal asymptote, and this is true for any function, occurs when or as x approaches infinity. Because think about it, if x approaches infinity and y and f of x approaches some, as x approaches infinity and f of x approaches some value, you're going to have a horizontal asymptote. For example, imagine the function f of x equals 1 over x. Well, as x approaches infinity, f of x approaches 0, hence it has a horizontal asymptote. And if you put in, I like to think, if you put in a billion, if you put in a billion into this, what would you get? Well, you get very, very close to 0. If you put a billion into this, what do you get? Well, I'll show you now in a second, but essentially you're going to get a billion over a billion, which is 1. You're going to get arc sine 1. But anyway, let's do it properly. We're going to do the limit as x approaches infinity of arc sine x squared minus 1 over x squared plus 1. Now you can go straight to, guys, this is the arc sine of 1, but I actually like to just kind of show it. So it's the limit as x approaches infinity of arc sine. So remember, what we're doing with limits is essentially subbing in infinity in here. What happens when you sub in infinity in here? Well, you get infinity over infinity, which we don't really want. So I divide above and below by x squared, and I get 1 minus 1 over x squared. So I'm dividing everything by x squared. I get 1 minus 1 over x squared over 1 plus 1 over x squared. And that's the reason why this goes to 1 over infinity is 0, 1 over infinity is 0, so these two will just disappear, and you're left with arc sine 1. And what's arc sine 1? Well, arc sine 1 is pi over 2, because the sine of pi over 2 is 1. Therefore, and guys, you have to write this down to get the final mark. You have to say horizontal asymptote is, and you have to write the equation. You can't just write pi over 2. You have to write y equals pi over 2, because it's a horizontal asymptote. It's going across that way, so it's y equals pi over 2. Okay, that's part A and B. Already, that's, you could argue, a tough 3 marks. Well, all that work just for 3 marks. Anyway, I'll do C and D in the next video.